Hello, friends. Welcome to my channel, Academic Made Easy Peasy. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be seeing NCERT Class 12 Mathematics, Chapter 5, Continuity and Differentiability. So now let us see the introduction to continuity first. Then in the next video, we will see the introduction for differentiability. Continuity and differentiability. So we have already learned differentiability or derivatives in class 11. Okay, so continuity and differentiability we will be learning in class 12. So we will be having the basics of 11 standard. With that we will be just doing the sums. So we will be learning continuity separately and differentiability separately. So now let us see what is continuity first. Continuity. So what is the basic concept of continuity? So continuity means is nothing but it is just like continuous. Okay, continuous. Continuity is nothing but continuous. So here what they are saying is that continuity of a function. So here continuity means a function will be given and we have to check whether the function is continuous. That is without any break it is moving or not, we will be seeing for the given function. So now let us see the mathematical definition for it. A function is continuous at x is equal to c if the function is defined at x is equal to c and if the value of function at x is equal to c equals the limit of the function at x is equal to c. So then it is nothing but limit x tends to c. It means x is something nearing c, maybe less than, mostly it is less than, or it might be greater than c in rare cases. So we are saying that limit of x tends to c, f of x is equal to f of c. If x is tending to c, then it means x is equal to c. We just imagine or assume like this only. So we will be just saying that f of x is equal to f of c. So if the condition is becoming true, then we say it is continuous or the function is continuous at the given interval or at the given position or point. If not, if we have any break or if the condition is not satisfied, then we say that it is discontinuous. So that is what is given here. If f is not continuous at c, then we say if it has discontinuous at c and c is called the point of discontinuity. So we will be just learning all these in the exercise sums detailedly. So now just have a gist of it. So now in continuity, this right hand limit and left hand limit, this is one of the important, because with this only we will be just proving whether it is continuous or not continuous or discontinuous. Okay, so right hand limit means, see, it is given if it is given as x tends to a, so we will be just taking x less than a first. That is called as left hand limit, a minus. Okay, so if we take x greater than a, we will be taking x tends to a positive. That we will be learning in the exercise detailedly. Okay, so we will be just saying for right hand limit and left hand limit. So now, so just see here, let us consider this as a line. Okay, so let us have this like this. So this is our left hand side. Yes, so this part is our left hand side and this is our right hand side. So if we have a point over here and we have to see the points lying here, so this is the point a, so we will be taking this as left hand limit where we will be subtracting a. And if we want to check the points over here, we will be taking the right hand limit, that is a plus. So here it will be a minus, here it will be a plus. So I'm just talking about this points over here. Okay, you need not to confuse. So that is what this will be, the formula which we will be using. So limit x tends to a plus f of x is equal to limit h tends to 0. So if we just take off this a plus, no, we will be just substituting here it as h tends to 0. So f of a plus h is equal to f of a. And here for left hand limit, we will be just saying f of limit x tends to a minus f of x is equal to limit h tends to 0. F of a minus h is equal to f of a. Anyway, this h is tending to 0. It means it is 0. So only we have written like this. So if these two, that is, yeah, this we will be just saying it as RHL and this is LHL. So if LHL and RHL is equal, then the function is continuous. If not, the function is not continuous. I think you will be more and more clear with this. Next, we will be learning about properties of continuity. So this properties of continuity is nothing but, see, a function will be given and we will be just checking continuity, no? So the proven facts only this properties of continuity says. Okay, so that is what I've just written here. Every constant function is continuous, that is any number will be continuous. So I think this will be clear. Every identity function is continuous. So every identity function, a function which is identity, that is identity function which we learnt in chapter 1, no, everything is continuous. Next, every polynomial function is continuous. So we know what is a polynomial function, no? So the every polynomial function is continuous, that is quadratic, cubic, whatever it is, every polynomial function is continuous. Then every trigonometric function is continuous. Every trigonometry functions, whatever functions we have learned now. So for example, let us have f of x is equal to sine theta. Okay, so this is continuous, that is limit x tends to 1. So f of x is equal to sine x. Let us have it as x. So sine x, let us have it as sine x. So if limit x tends to 1, f of x is equal to sine x. So this will be the trigonometric function and this is continuous. It is already proven. Then every algebraic function is continuous. So they are saying that every algebraic function is continuous. Next, if f and g are two continuous functions, let's say f of x and g of x, okay, are continuous in the domain D, then f plus g, that is f of x plus g of x, okay, so f of x plus g of x is continuous. Then f of x minus g, whether it is f or g, it means that if f minus g is said, then it means that f of x minus g of x, you have to understand. And next here c, f, here c is nothing but a constant. Okay, c is nothing but a constant. Any constant function into the function f of x is continuous. Then f into g, that is a multiplication of two continuous function, is always continuous. And then the continuity of the division of the two continuous function is also continuous, they are saying. Next, if f is continuous, then mod of x is also continuous. That is, any modulus function is also continuous. Then, if f and g are real valued function in FOG, if g is continuous at c and f is continuous at g of c, then FOG is also continuous. That is, if f and g are some real valued function that we learnt in real relations and functions, no? So if g is continuous, then they are saying that FOG is also continuous. Now let us learn about some important results. So here results means all that is what I said. No, we already saw some already proven pre-proven facts. So here this also is some points where you have to remember in order to do the sums. So see here, first it is given that sin x is continuous at all points. So here for the trigonometric sums, no, so what we will be just doing, so wherever the function sin x or cos x or tan x, whatever it is, if it is not defined or infinity, then we say that the function is not continuous. Okay, so at this point of infinity or not defined, the function is said to be discontinuous. Okay, so since sin x do not have this not defined, we are saying that sin x is continuous at all points. And if you just see for cos x also does not have any not defined, so therefore we say that cos x is continuous at all points. See, only in trigonometric sums, only sin x and cos x will be continuous at all points. You have to remember this very carefully. So sin x and cos x alone will be continuous at all points. Other functions will be discontinuous at some points. So next it is tan x. So tan x is continuous at all points except x is equal to 2n plus 1 pi by 2 where n is some integer. So just see here, when is tan not defined? So tan is not defined at pi by 2. Here when let us start n is equal to 0. Okay, so when we just apply it over here, x is equal to n plus 1 pi by 2. So when n is equal to 0, 2n will become 0. So pi by 2. So pi by 2 tan is not defined. So next if we just take 2. Okay, so 2 2 2s are 4. So 4 plus 1 into pi by 2. So 5 pi by 2, it is not defined when n is equal to 1. Okay, so we are just substituting the value of n over here as 1. So we will be having 2 plus 1 pi by 2, which is 3 pi by 2. So at 3 pi by 2 also tan is not defined. No, so therefore at all these points tan x will be discontinuous. So that's what it is said, that tan x is continuous at all points except at x is equal to 2n plus 1 pi by 2, where n is some integer. So you have to remember this. The next what is said here is that cosecant x is continuous at all points except at x is equal to n pi, where n is some integer. So as I taught you for the tan x, you can just substitute for cosecant, secant and cot. So cosecant is not defined at 0, that is 0 degree. Then it is not defined at pi. Okay, then it is not defined at 2 pi. So when we just substitute the value of n as 0, 1, 2 at all these points, cosecant will be not defined. So therefore it is discontinuous at those points. Next, secant x is continuous at all points except at x is equal to 2n plus 1 pi by 2. So that is odd positions. No, that is 1 pi by 2, then it is 3 pi by 2, 5 pi by 2. At all these points, secant is not defined. If you just check the table which we learnt in 11th standard or the value table, you will understand it more, and if you just substitute and see, you will understand it. Next, cot x is continuous at all points except at x is equal to n pi, where n is some integer. So if you just check the table again, you will understand it, and just substitute the value of n and c. You at all these points, cot will be not defined. So therefore these are the points where cot x will be discontinuous. So now let us learn some important results. So here for continuous, okay. So limit x tends to 0, sin x by x is equal to 1. So this all we have already learned in class 11. So this will be easy, I think. So when x is tending to 0, then the function sin x by x will become 1. And next, limit x tends to 0, sin x by x will become 0. So limit x tends to infinity means what? Infinity means here it is some x by 0 only, no? So let us have this as infinity as x by 0 itself. We need not to take any number. So it is sin x by some, need not to substitute over here, x by 0. So in the next step, how will we write? Sin x into 0 by x. No, 0 into something is 0. So 0 by x. So it will automatically become 0. That is what proven over here. Next, limit x tends to a, x power n minus a power n divided by x minus a is n into a power n minus 1. So this is one of the important result. So we have already learned more detailedly in 11th standard. So these are the just important points where you have to know. That's why I just gave. You have already learned in 11th standard. So I'm just moving it fast. If you have any doubts, you can just mention it in the comment box. I will make you clear. Next, limit x tends to 0, tan x by x will become 1. So when limit is tending to 0, then for sin x, tan x, everything, no, that will become 1. And even for sin inverse of x by x. So when limit x is tending to 0, for sin x, tan x, and sin inverse x, okay, for all these the value will become 1. And even for tan inverse x, okay. So for all these four functions, no, sin inverse, sin x, sin inverse x, tan x and tan inverse x, for all these, when the limit is tending to 0, the function will become 1. Everything is continuous only, okay. Next, I said no already. When limit x is tending to 0, tan inverse x by x will become 1. And here when limit is tending to 0, e power x minus 1 divided by x is equal to 1. So when x is 0, this e power x minus 1 by x also will become 1. Next, limit x tending to 0, a power x minus 1 by x is equal to log EA. So this is one of the important formula. We will be doing it in integrals, not here. Mostly we will be using this in integrals, so we will learn it there. Next, limit x tends to 0, log 1 plus x divided by x is equal to 1. Next, limit x tends to 0, 1 by 1 plus x, the whole power 1 by x is equal to e. So e is nothing but the exponent function. And next, when limit x tends to infinity, 1 plus 1 by x, the whole power x will become e, that is the exponent function. Stay tuned for introduction to differentiability. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.